In earlier lessons on binary, I showed you the basics of how to count like a computer. In this lesson, I'm going to begin to show you how to think like one. Before we begin, however, I need to introduce you to a new concept as well as a new term, the Boolean. Now, what exactly is a Boolean? A Boolean is simply a thing that can be set to only two values. For example, true and false, or 1 and 0. Now, because a bit can also only have two values, 1 and 0, we can think of a bit as a kind of Boolean. That means that operations and concepts that apply to Booleans also apply to bits. And it is this fact that makes understanding Booleans useful. Now, there are two reasons that you should learn Booleans. The first is complex programming logic relies on Booleans. Whenever you need to determine something beyond a simple comparison, you would use Booleans to do so. Secondly, the ability to manipulate data by manipulating individual bits requires that you understand Booleans. In fact, we'll be looking at examples of this very soon. The science of studying Booleans is rooted in the study of logic. In fact, Boolean operations can be thought of as logical operations. Let me show you a simple example. Suppose I told you everything I say is false. Then you know that whatever I tell you, you simply need to flip its meaning. If there are only two possible values, true and false, then you know to apply the following rule. If I give you a true, you change it to a false, and if I give you a false, you change it to a true. Now, if we think about this in terms of binary, we could say this. If I give you a 1, you change it to a 0, and if I give you a 0, you change it to a 1. This is the simplest kind of Boolean operation called NOT. NOT just simply flips the value given to it. Here is how NOT works. NOT 1 is 0, and NOT 0 is 1. Notice that NOT only requires a single input and gives back a single output. This is what makes NOT the simplest of the Boolean operators we're going to be looking at. Now, let's suppose that I told you two statements. The earth is round and the sky is up. Now, suppose I told you to evaluate whether I told you the complete truth or not. For this to be the complete truth, both statements must be true. If either statement is false, then I have not given you the complete truth. We can think of this as a Boolean operation requiring two inputs, and that both inputs must be true for the output to be true. In other words, we can say it like this. True and true is true. True and false is false. False and true is false. And of course, false and false is false. Both statements have to be true for the whole thing to be true. Now, if I wanted to express this same concept with ones and zeros, where 1 is true and 0 is false, we could say it like this. 1 and 1 is 1. 1 and 0 is 0. 0 and 1 is 0. And of course, 0 and 0 is 0. This is an example of what is called a truth table. A truth table is a table showing all of the possible inputs and the final result for a given Boolean operation. In this case, we are looking at the Boolean operation called AND, which takes two inputs and returns a single output. Alright, now let's take a look at another operator named OR. The way OR works is very simple. If either input is true, or 1, then the result will be 1, including if both of them are set to 1. So for example, 1 or 1 is 1. 1 or 0 is 1, because at least one of the inputs is 1. 0 or 1 is 1, and the only way that the final result will be 0 is if both inputs are 0, and so 0 or 0 is 0. So now we've looked at 3 Boolean operators. We've looked at not, and or. Now there are many other examples I can give you, and in fact there is a whole branch of mathematics devoted to this, which is called Boolean algebra. This is a fundamental topic for electronics, and because computers are electronic devices, the value of understanding Booleans carries over into programming. So let's recap some of what you just learned. First of all, a Boolean is a thing that can be set to one of 2 values, such as 1 or 0, which is synonymous with true and false. Also, a Boolean operator uses a specific set of rules in order to change one or more Booleans into a new Boolean. Now, one major concept to understand is that when you are working with a Boolean, you can only ever get a Boolean back. In other words, any mixture of operations involving ones and zeros will result in a single 1 or a single 0. So keep in mind the following. Each Boolean operator takes a set number of inputs. In the case of AND, as well as OR, that number is 2. This means that AND, as well as OR, takes exactly 2 inputs. Both inputs are Booleans, and then of course results in a single Boolean as output. Every Boolean operator will have a truth table. The truth table will show all possible results for that operator. The number of rows for such a truth table will always be 2 to the power of the number of inputs required. For example, OR has 4 results in the truth table because it has 2 inputs, and 2 to the power of 2 is 4. And final point, no matter how complex the operator or mixture of operators, the final result of any Boolean operation is a single Boolean. Okay, now let's try mixing 2 different Boolean operators together. Suppose I said not or. How would we do that? Well, first of all, we would construct the truth table for or, which looks like this. And now, because we are applying not, all we have to do is just flip each of these bits around, like so. And now we have our truth table for what is called NOR, which is another way of saying not or. And likewise, we can do the same thing for not AND, which is called NAND. And the way that works is, first of all, we place our truth table for AND. Now, because we're applying not, we just simply flip around the bits, like so, and we have constructed our truth table for NAND. So from this lesson, you should be able to, on your own, construct a truth table for not, or, and, nor, and NAND. Now, in the field of electronics, these Boolean operations are formally known as logic gates. So the way that a logic gate, in this case we're looking at the AND logic gate, actually works is that each of the inputs correspond to 2 incoming wires, and the output corresponds to the outgoing wire. The outgoing wire will have an active current only if both incoming wires have an active current. Think of the 2 incoming wires as the Boolean inputs, and think of active current as 1 and no current as 0. If both wires are active or set to 1, then the result is a wire with active current. In other words, 1 and 1 is 1. Now, the reason I'm teaching you this is because C, as well as many other programming languages, give you the ability to work with Booleans on this fundamental level. And as you will see, it can be very useful. Besides using it in your own programs, you are likely to come across it being used in programs that other people have written. Remember that underneath it all, your computer is simply a very complex electronic device. Logic gates play a major role in how your computer works, and by understanding Booleans, you will be able to perform more powerful operations on data, as well as understand your computer at a deeper level. Alright, that concludes this lesson.